going to go over a few of the Math 3 Unit 6 Worksheet 7 problems on graphing radical equations, starting with number 3. Here we have y equals negative square root of x minus 2. And here we're working off of the parent graph, y equals the square root of x. And from your notes, you should have seen kind of what that parent graph looks like, that it goes through, it starts at the point 0, 0, because to make a table of points here, plug in 0 for x, you get 0 for y. You plug in 1 for x, you get 1 for y, so 1, 1. And then 2, you get a square root of 2, which is hard to graph. So you want to pick perfect squares, so square root of 4, which is 2. So if you go right 4, you go up 2, and you get this curve, keeps going to the right, and the domain starts at 0, because we cannot plug any negative numbers into this, because you can't take the square root of a negative number, so x has to be greater than or equal to 0 for our domain. So now let's apply that to number 3 here. So number 3, we've translated down 2 units, and we've reflected over the x-axis. So let's make that reflection first. So when we reflect, it's kind of looking something like this, and then translate it down 2 units. So a point at so that point at 0, 0 has been moved down 2, and we can get a couple extra points by making a table of values here. So 0, we could just check here. If I plug in 0, I get negative square root of 0 minus 2, which is negative 2. And that's what I had here. Let me get some more space here. If I plug in 1, I get negative square root of 1 minus 2, which is going to be negative 1 minus 2, or negative 3. So I could plot that at 1, negative 3. And if I plug in 4, I get negative square root 4 minus 2, which is negative 2 minus 2, or negative 4. So go right 4, down 4. And that gives us a sketch of our graph. For our domain, we can't take the square root of a negative, and so that what's underneath the square root is x, and that needs to be greater than or equal to 0. And that's what we see in our graph. And so our domain is everything starting at 0 all the way to the right to infinity. And the range, the highest it goes is up at, we see at negative 2 for the y value, and it keeps dropping, and it will slowly keep dropping as low as we want. So the lowest is negative infinity up to the highest at negative 2. Use brackets because we include that value. So in number 5, we get our first point from the translation. This has been translated to the right 2 units because we see the x minus 2 together underneath the square root, and we're moving up 1 unit. So if we move from 0, 0, move to the right 2 units up 1, we get our beginning point at 2, 1. And if we make a table of values here, we can check to make sure this is correct. If I plug in 2 for x, I end up with negative 2 times the square root of 2 minus 2 plus 1, which that's going to be negative 2 times the square root of 0 plus 1. And negative 2 times 0 is 0, so we end up with 1, and that's what we thought. So let's get a couple more points. If I plug in 3, I'm going to get negative 2 times the square root of 3 minus 2 plus 1, which is negative 2 times the square root of 1 plus 1. Square root of 1 is 1, and so we end up with negative 2 plus 1, which is negative 1. So 3, negative 1. So we see this is starting to open down, which makes sense because we have a negative 2 out in front, which reflects this thing downward. And then for our next choice, we need to pick an x value that's going to give us a square root that we can work with. If I pick 4 for my next value, I'll get the square root of 4 minus 2, which is square root of 2. Not going to work out so nice. So the next one that will work out nice is if I plug in a 6. Because when I plug in 6, I get the square root of 6 minus 2. And 6 minus 2 is 4, and I know how to get the square root of 4. Works out nicely to negative 2 times 2 plus 1, which is going to be negative 4 plus 1, or negative 3. So 6, negative 3. So 1, 2, 3, 4, 5, 6, down 1, 2, 3. Something like that. And I see that I made a graphing error. I was supposed to graph my second point at 3, negative 1. I put it at 3, 0. So I'm going to fix that. So get this kind of rounded side here. It's the bottom half of a sideways parabola is what we're drawing here. So for the domain, the part underneath our square root is x minus 2, and that part has to be bigger than or equal to 0, because if it's not, it will have a negative value giving us something that's not real. So I'm going to add 2 to both sides of this, and I get x has to be bigger than or equal to 2. So our domain is everything starting at 2 to infinity. And we see that in our graph. The range, it will keep dropping as low as we want, so the lowest is negative infinity. And the highest we see, the maximum value, is at 1. And include that 1. Next, let's take a look at number 7. Here we're asked to sketch the graph for each of the following and find or solve for the indicated information. So first, let's sketch, and then second we'll go through A through D. So in our sketch, the parent graph starts at 0, 0, but this is translated up 4 units. So 0, 4 is our starting point. I'm going to make a table of values. We can even check that. If I plug in 0, I should get 4, and we do. 0 plus 4 is 4. Next, I'm going to plug in a 1. Square root of 1 plus 4 is 5. So 1, 5. And again, I plotted my first point wrong. Should be 1, 0, 4. I put it at 0, 3. Next, I'm going to plug in a 4. I get the square root of 4 plus 4, which is 2 plus 4, or 6. So x is 4, y is 6. Right here. And so that's what we get. We get the top half of a sideways parabola. So our domain is all x values greater than or equal to 0, because we can't take the square root of a negative, or we could write it as start at 0, go to infinity in interval notation. For the range, the lowest we see is at height 4, and it goes up to infinity. For the x-intercept, you find x-intercepts by plugging in 0 for y, and when we do that, we get 0 is equal to the square root of x plus 4. Solving for x, I subtract 4, and you end up with negative 4 is equal to the square root of x, which does not make sense, because when you take the square root of a number, you should not have a negative answer. It has no solution. And so what this is saying is that we have no x-intercept. If we look at our graph, we could see why. This thing will never cross the x-axis. On the other hand, so for the range, for the y-intercept, we plug in 0 for x, and you end up with y equals the square root of 0 plus 4, which is 4, and we see that in our graph as well. The y-intercept is at 4, or if you could put it as a point at 0, 4. We want the open interval where f is increasing. If we look at our graph, as you trace it from left to right, it's moving up, and so this is increasing over its whole domain. So I'm just going to copy down the domain from 0 all the way to infinity. And actually it says open intervals, so instead of brackets we use parentheses. Because open represents parentheses. Next, the average rate of change. The average rate of change is a slope. And so we're looking for the slope when x is, we're going to start from 0, so we're going to have x be 0 and then x be 9. And so we need to find y values for those. We know that when x is 0, we get y as 4. We haven't taken a look at what happens when we plug in a 9. When we plug in 9, we get the square root of 9 plus 4, which is 3 plus 4, or 7. And so 0, 4 and 9, 7 are what we're going to use for our slope. So the average rate of change, or the slope formula that we use, is you take your two different y values and subtract them, divided by the difference of your two x values. You get to decide which y value you want first, and which one second. So I'm going to choose the larger y value first, so 7 minus 4. Those are our two y values. Because I chose 7 first, I have to choose 9 first, because 9 went with the 7. There's that ordered pair, and minus 0. So 7 minus 4 is 3 over 9, and this reduces to 1/3. So my average rate of change from 0, for x being from 0 to 9, is 1/3. Lastly, I want to take a look at number 9. Again, we were asked to first graph this, and we're going to start with the translation. We're moving left 2 units and down 3 units from 0, 0. And that gives us our starting point. We can check that. If I plug in 2 for x, we get, if I plug in negative 2 for x, I get the square root of negative 2 plus 2 minus 3, and that's 0 minus 3, or negative 3, and that's our starting point. Next, I'm going to plug in a negative 1, because when I do, I end up with the square root of 1, because negative 1 plus 2 is 1. So square root of 1 minus 3, which is 1 minus 3, or negative 2. So negative 1, negative 2. And lastly, I'm going to plug in a 2 because I'm trying to create the square root of 4. And we have 2 plus 2 underneath the square root sign, which is the square root of 4 minus 3, or 2 minus 3, which is negative 1. So x is 2, y is negative 1. Our graph looks like this. So the domain we could see from the graph is, it starts at negative 2. This is the domain, and it goes to infinity. The range from the graph goes, the lowest point has a minimum at negative 3, and it slowly rises to infinity. Let me fix that. It should be negative 3. X and y intercepts. If we plug in 0 for y, we get our x-intercept. So 0 is the square root of x plus 2 minus 3. And we want to get our square root by itself, so I add 3 to both sides, and I get 3 is equal to the square root of x plus 2. Next, to get rid of the square root sign, we square both sides and end up with 9 is equal to x plus 2. And lastly, we subtract 2 from both sides and get an x-intercept at 7. So my x-intercept is the point 7, 0. For the y-intercept, we plug in 0 for x, and we get y is the square root of 0 plus 2 minus 3, which is the square root of 2 minus 3. And that's as much as we can get without a calculator. And you see it's a decimal value. Even in our graph, we see it's somewhere between, it's crossing the y-axis somewhere between negative 1 and negative 2. C, the open interval where h is positive. So our graph is going to be positive when it's above the x-axis. So when it says h is positive, it's meaning above the x-axis. Well, our graph, as we see, is below the x-axis until it hits the x-intercept. Where is it going to hit the x-intercept? Well, in part B, we see it hits the x-intercept at 7. So 1, 2, 3, 4, 5, 6, 7, about right here. So once it hits that, after that, it's going to be above the x-axis for the rest of the time. So it's an open interval, so only use parentheses when it says open interval. So starting at 7 and continuing on as far to the right. Lastly, we are looking for the average rate of change when x is negative 1 and when x is 7. When x is negative 1, we already plugged that in and found that y is negative 2. When x is 7, if we look at our x-intercept, we know that y is at 0. And so using the slope formula, because average rate means the slope, we're going to get the slope, or the average rate, is y minus y. So I'm going to go 0 minus a negative 2, double negative, is 7 minus a negative 1, double negative again. So that's positive 2 over 8, which reduces to 1/4. Alright, number 11. We have f of x equals 3 minus 2 times the square root of x plus 4, which is the same as f of x is equal to negative 2 square root of x plus 4 plus 3. And so that 3 can be up front or at the end, but you want to see that translation. The plus x plus 4 moves us left 4 units, and then that plus 3 up 3 units from 0, 0. So that's our starting place. Because there's a negative 2 in front, we know it's going to decrease from that point down and to the right. Domain and range I'm going to hold off on. Let's do the x and y intercepts first. So if I plug in 0 for y, find the x-intercept. So I'm going to subtract 3. Divide by negative 2. Square both sides. And 9 over 4 as a decimal, well, 4 goes into 9 2 times with a remainder of 1, so it's 2 and a quarter, or 2.25. So subtract 4 from that, and we have negative 1.75. So that's where we're going to cross the x-axis, at 1.75. For the y-intercept, plug in 0 for x, and we get f of 0 is 3 minus 2 times the square root of 4. Or negative 1. And I'm realizing I put the x-intercept in the wrong spot. It should be at negative 1.75. So x-intercept at negative 1.75, y-intercept at negative 1. So we see now that the domain goes from negative 4 to infinity, and the range goes from negative infinity up to 3. Our average rate of change when x is negative 3, well, we know we have that point. When x is negative 3, actually we don't have that point yet. We need to find out what y is. And when x is 5, we've got to find out what y is. So I'll use a table here. So negative 3, we get negative 2 times negative 3 plus 4 underneath the square root, plus 3. So we get 1, so negative 3, 1. And if we plug in a 5, we end up with negative 3. So now we want to find the average rate of change, which is the same thing as the slope. So you take your two y values and subtract them, divided by the difference of your x values. Watch out for double negatives. So this reduces to negative 1/2 is our average rate of change from x equals negative 3 to x equals 5. And lastly, the open interval where f is positive, or in other words, where f is above the x-axis. So it starts at -4 and goes to our x-intercept, which was at -1.75.